Today we are going to talk about the standard error of the mean and confidence intervals. Now the standard error of the mean, it tells us about the differences between the population mean and the sample mean. It is the estimated standard deviation of the population, not the sample. The standard error of the mean also cannot be negative. Now a confidence interval is a range of numbers in which the population mean is most likely contained. So when you calculate your confidence intervals, you're going to get a set of two numbers, and in between those two numbers is most likely where the population mean is going to be. Let's get started. The standard deviation of the population of individual pulse rates is 5.00 beats per minute. A random sample of 100 participants yields a mean pulse rate of 73 beats per minute. Find the standard error of the mean. So first off, what do we need? We need to find the standard error of the mean. Now, if you look in your textbook or your notes, there are a number of different formulas that are given to you. So depending on what the problem is giving to you, you will use the corresponding formula. If the problem gives you the standard deviation, this is going to be the formula that you use. If the problem gives you the raw score or raw scores, then this is going to be the formula that you use. And later on in the video, we are going to go over confidence intervals, and so those are the formulas for the confidence intervals. So what are we given here? We are actually given the standard deviation. We have right here the standard deviation of the pulse rates is 5.0. So we actually have a standard deviation of 5.00. And then we also have the N value here, which is 100 participants. Okay, so let's go ahead and take that information and see what we can do with it. Now, if our standard deviation is given, this is going to be the formula that we use. So let's go ahead and write that out. So we have the standard error of the mean equals the standard deviation over n minus 1, and that is square root. Okay, so let's go ahead and plug those numbers in. So the standard deviation is 5, and then we have a sample size of 100 minus 1. Okay, so that is going to be 5.00 over the square root of 99. Go ahead and solve for that square root. So 500 square root of 99 is 9.95. So when you divide 5.5 by 9.95, we get 0.50. So our standard error of the mean for this problem is 0.50. So in the previous example, we looked for the standard error of the mean using the formula if the standard deviation was provided. So in this example, the standard deviation is not provided. So if you look at our formulas here, this is the formula that you are going to have to use because the standard deviation isn't given. Instead, you are given a set of raw scores. So let's go ahead and write that down here. So the standard error of the mean Okay, so we need our standard error of the mean. In order to solve this, we need the x squared, we need the n value, and we need the mean value. Okay, so finding n is simple. You just count how many people are in your sample. So we have 1, 2, 3, 4, and 5. So our n value is 5. Okay, let's go ahead and find our mean. So to find the mean, we will use this formula. So this just means the sum of x, the sum of raw scores. So you're just going to add all those scores up. So add 3, 6, 2, 4, and 5. When you add those up, that's going to give you 20, divided by our n value, which is 5. So that's going to give you 4. So our mean is 4. Okay, so now let's go ahead and square all the values here. So 3 squared is 9, 6 squared is 36, 2 squared is 4, 4 squared is 16, and 5 squared is 25. Okay, so in order to get this value, we just have to add all of these up, and when we add those all together, that's going to give us 90. Okay, now we have everything that we need to just plug in the numbers here. So our EX squared value is 90 divided by our N value of 5 minus the mean squared, which is 4 squared, over our N value of 5 minus 1. And then we are going to square root all of that. Okay, so 90 divided by 5 is 18. And then 4 squared is 16. 5 minus 1 is 4. So 18 minus 16 is 2. Divided by 4 is going to give us 0.5. And then when we go ahead and figure out the square root for that, that is going to give us 0.7071067. Okay, and don't forget that we need to round. So our final answer, standard error of the mean, is going to be 0.71.